So the next one is f of x times g of x. And guys, again, this is basically as simple as taking f of x and multiplying it times g of x. That's all that means. Take one function, multiply by the other function. So f of x is 3x squared, and you're going to multiply it times x minus 3. You can't multiply outside of radical, inside of radical. So this is really like as far as you can go. There's really not much we can do to simplify this from here. So it's done. But I'm not really concerned in this case as far as the operations. I'm concerned about what do you know about the domain. So we see here quadratic. OK, negative infinity to infinity. Here we see, oh, it's a radical. Everything when you have a radical, you always have to set it greater than or equal to 0, right? X has to be greater than or equal to 3. So therefore, 3 to infinity. Hopefully, since this is on the last quiz, you guys are comfortable with me doing that work, because that's what we need to remember from last quiz. And guess what? It shows back up on this quiz. So if you were confused on that, or still are, you still have a couple more days to make sure you're good with that, because it's going to show back up. So we have a domain that's all real numbers, and then a domain that's restricted. So the best way to understand this is let's draw the domains on the number line. One domain is only good for values 3 to infinity. So it's only good for numbers that are greater than 3. The other one is true for all values. However, when we're adding, subtracting, or multiplying, we're only taking the domain of where they are the same, or the combination, or the intersection of the two. So where do these two domains intersect? From 3 to infinity, right? So the domain of this function, which looks really weird, right? It's like, ooh, I don't know what that looks like. But the domain is just the combinations of the two functions. So that's going to be 3 to infinity. So what's nice about these is people get very confused by looking at the graph. They're like, oh, man, I don't know what the graph looks like. And because that's how they want to always do the domain.